Hello everyone, today I'm excited to present Tutor-AI, an AI-powered personalized tutoring platform designed specifically for IITJEE aspirants. While modern large language models like ChatGPT and Gemini are incredibly capable, they are general purpose models. They aren't specifically designed to teach highly specialized subjects like JEE, mathematics, physics, and chemistry. They also don't adapt to an individual student's strengths, weaknesses, or long-term learning progress. Our goal with Tutor-AI was to build something beyond a traditional chatbot. Instead of simply answering questions, Tutor-AI acts as a personal AI tutor that continuously learns about the student, identifies weak concepts, generates personalized assessments, and provides targeted guidance to improve understanding. The platform allows students to upload their notes, upload images of handwritten or printed questions, or simply type their doubts directly into the chat interface. Rather than producing generic responses, Tutor-AI retrieves relevant context, reasons through the problem using multiple specialized AI agents, and generates accurate, structured explanations. One of the major goals of this project was to encourage conceptual understanding instead of memorization. Let's begin by exploring some of the key features of the platform. The first feature is our adaptive assessment system. Unlike conventional quiz generators that produce random questions, Tutor-AI continuously analyzes the student's previous conversations. Every doubt asked, every incorrect explanation, and every topic discussed contributes to the student's learning profile. Using this information, Tutor-AI automatically identifies weak topics and generates personalized quizzes focused specifically on those areas. As the student improves, the difficulty level and question selection also evolve, creating a truly adaptive learning experience. The second major feature is teach-back learning. Educational research has shown that one of the best ways to verify understanding is by asking students to explain concepts in their own words. Tutor-AI follows the same principle. After providing a detailed explanation, the AI asks the student to explain what they understood. Instead of checking for exact wording, the platform evaluates conceptual understanding using semantic analysis. It identifies which important concepts were successfully explained, which ideas were partially understood, and which concepts were completely missed. This information is then used to update the student's mastery level for that topic. As a result, Tutor-AI doesn't simply answer questions, it actively measures learning. Another useful feature is our integrated problem scanner. Students frequently solve questions from textbooks, notebooks, or coaching materials. Typing lengthy mathematical questions is both slow and inconvenient. To solve this problem, Tutor-AI integrates a vision language model that performs OCR and visual understanding. Students simply upload an image of a question. The system automatically extracts the text, understands mathematical expressions and diagrams, and forwards the extracted content into the AI reasoning pipeline. This creates a much smoother user experience while significantly reducing the effort required to ask doubts. In addition to personalized tutoring, Tutor-AI also provides detailed learning analytics. Every interaction contributes to a continuously updated student profile. The analytics dashboard visualizes subject-wise performance, topic mastery, learning velocity, and overall learning progress. Instead of guessing which subjects need improvement, students receive clear insights into their learning journey, helping them allocate their study time more effectively. These features together transform Tutor-AI from a simple AI chatbot into a complete personalized learning platform that continuously adapts to every student's individual needs. One of the biggest differentiators of Tutor-AI is its multi-agent architecture. Instead of relying on a single language model to perform every task, Tutor-AI uses a team of specialized AI agents where each agent is responsible for a specific part of the reasoning process. This architecture is implemented using LangGraph, which allows us to build dynamic workflows between multiple AI agents instead of executing a simple linear pipeline. Whenever a student submits a question, the request first reaches the orchestrator agent. The orchestrator acts as a central decision maker of the system. Its responsibility is to understand the user's intent and determine which specialized agents should participate in solving the query. For example, if the student asks a straightforward conceptual question, the tutor agent alone may be sufficient. However, if the question requires external context, retrieval from uploaded notes, or deeper reasoning, the orchestrator dynamically routes the request to multiple agents simultaneously. The first specialized component is the research agent. This agent performs retrieval augmented generation, or RAG. Instead of relying entirely on the language model's internal knowledge, it searches the uploaded study material, retrieves the most relevant information, and provides factual context for answering the question. This ensures that the AI can answer based on the student's own notes instead of producing generic responses. Alongside the research agent, the tutor agent focuses on generating educational explanations. Rather than simply producing the final answer, it explains concepts step by step, making the solution easier to understand for students preparing for competitive examinations. Once these responses are generated, they are forwarded to the critic agent. The critic agent acts as a quality assurance layer. Instead of immediately returning the generated answer, it carefully evaluates whether the explanation is complete, logically consistent, and educationally useful. If it detects missing information, weak reasoning, or incomplete explanations, it sends feedback back to the appropriate agents. Those agents refine their responses and submit improved versions for another review. This evaluation loop continues until the critic agent is satisfied with the overall quality of the response. This iterative refinement significantly improves answer reliability compared to a traditional single-pass chatbot. Another important component is the memory agent. The memory agent continuously tracks the conversation history and maintains long-term context throughout the learning session. Instead of treating every question independently, Tutor-AI remembers previous discussions, allowing it to generate responses that are personalized to each student's learning journey. Finally, once every agent has completed its task, the response reaches the composer agent. The composer is responsible for combining all intermediate outputs into a single, well-structured answer. It formats mathematical explanations, organizes retrieved information, improves readability, and produces the final response that the student sees inside the chat interface. By dividing responsibilities across specialized agents, Tutor-AI achieves higher accuracy, better reasoning, and more personalized explanations than a traditional AI chatbot. Now, let's briefly discuss the technology stack behind the project. The front end is developed using React, providing a modern and responsive user interface. The back end is implemented using Fast API, which exposes REST APIs and manages the complete AI workflow. The multi-agent orchestration is built using LangGraph, enabling dynamic routing and communication between different AI agents. For authentication and database management, we use Supabase, which stores user information, uploaded documents, chat history, learning analytics, and topic mastery. The platform also integrates vision language models for OCR, retrieval augmented generation for document understanding, and specialized language models for tutoring, reasoning, orchestration, and evaluation. Together, these technologies create a scalable AI tutoring platform capable of delivering personalized learning experiences for every student. Now let's move on to the live demonstration of Tutor-AI. After signing in, we arrive at the main dashboard. This dashboard provides a complete overview of the student's learning progress. Instead of displaying only chat history, Tutor-AI continuously analyzes every interaction and converts it into meaningful learning insights. At the top, we can see the overall learning analytics. These include the subject radar chart, which shows a student's relative proficiency across physics, chemistry, and mathematics. As a student interacts with Tutor-AI over time, this visualization automatically updates, allowing them to immediately identify weaker subjects that require additional practice. Next, we have the learning velocity metric. This tracks how quickly the student is improving over time based on completed assessments, solved doubts, and concept mastery. Unlike traditional learning platforms that only track marks, Tutor-AI attempts to measure actual conceptual growth. We also display topic mastery, which shows how confident the platform is about the student's understanding of different concepts. Each topic evolves continuously as the student asks questions, attempts quizzes, and participates in teach-back sessions. Now, let's move to the main chat interface. This is where students interact directly with Tutor-AI. A student can type a question, upload study notes, upload handwritten questions, or even upload images from textbooks. For this demonstration, we're uploading a question. As soon as the question is submitted, the request enters our multi-agent workflow. The first component that receives the request is the orchestrator agent. The orchestrator analyzes the question and decides which specialized agents are required. If the question only requires conceptual explanation, it forwards the request directly to the tutor agent. If the question requires retrieval from uploaded notes, external reasoning, or additional verification, it dynamically routes the request to both the research agent and the tutor agent simultaneously. This dynamic routing allows Tutor-AI to allocate computational resources efficiently instead of processing every request through every available agent. As each agent finishes its task, the results are passed to the critic agent for evaluation. Instead of immediately returning the answer, the critic checks whether the explanation is complete, logically consistent, and educationally useful. If improvements are needed, feedback is sent back to the appropriate agents. This iterative review process continues until the response satisfies the required quality standards. One feature I'd like to highlight is response streaming. Rather than making the student wait until the entire pipeline completes, Tutor-AI streams intermediate responses while the remaining agents continue processing in the background. This significantly improves the perceived responsiveness of the application. From the user's perspective, the platform feels much faster because useful information begins appearing almost immediately. Once all participating agents complete their work, the response reaches the composer agent. The composer combines outputs from the tutor agent, research agent, and critic agent into a single, well-structured explanation. It formats equations, organizes important concepts, removes redundant information, and produces the final response shown to the student. Now, let's look at one of Tutor-AI's most important educational features, Teach Back Mode. After reading the explanation, the student can activate Teach Back Mode. Instead of ending the conversation after answering the question, Tutor-AI asks the student to explain the concept back in their own words. This transforms passive learning into active learning. The student's explanation is evaluated using semantic understanding rather than exact keyword matching. The system identifies concepts that were correctly understood, partially understood, or completely missed. Based on this evaluation, Tutor-AI updates the student's mastery profile and uses this information while generating future quizzes and recommendations. As a result, every interaction contributes to a personalized learning experience instead of remaining an isolated question and answer session. This adaptive feedback loop is one of the core ideas behind Tutor-AI and plays a major role in making the platform function as a true AI tutor rather than a conventional chatbot. Now let's demonstrate another important capability of Tutor-AI, Retrieval Augmented Generation, commonly known as RAG. For this demonstration, I have already uploaded my resume to the platform. Instead of relying only on the language model's internal knowledge, Tutor-AI first retrieves the most relevant information from the uploaded document before generating the response. Now I'll ask the assistant about one of my projects. As soon as the query is submitted, the request once again enters the multi-agent workflow. The orchestrator analyzes the question and recognizes that the required information exists inside the uploaded document. Instead of generating a generic answer, the research agent searches through the index document embeddings and retrieves only the most relevant sections related to the requested project. These retrieved passages are then forwarded to the tutor agent, which combines the retrieved context with its reasoning capabilities to generate a comprehensive explanation. The critic agent verifies that the generated response accurately represents the information present in the uploaded document before allowing it to reach the user. As we can see, the platform doesn't simply copy text from the document. Instead, it understands the retrieved information and presents it in a well-structured and easy-to-read format. This approach significantly improves factual accuracy while reducing hallucinations, making Tutor-AI much more reliable for educational use. Next, let's look at the Vision OCR pipeline. Students frequently ask doubts using photographs of textbook pages, handwritten notes, or coaching assignments. Typing these questions manually is inconvenient, especially when mathematical equations or diagrams are involved. To solve this problem, Tutor-AI integrates a vision language model capable of understanding both text and visual content. Here, we upload an image containing a question. The vision model first extracts all the textual content from the image while preserving the mathematical expressions and important contextual information. After extraction, the recognized text is automatically forwarded to the orchestrator agent. From this point onward, the request follows exactly the same multi-agent reasoning pipeline that we observed earlier. The orchestrator determines the required agents, the research and tutor agents generate the explanation, the critic validates the response, and finally, the composer formats the complete answer before presenting it to the student. This seamless integration allows Tutor-AI to support both text-based and image-based learning without requiring separate workflows. By combining Vision AI, retrieval augmented generation, adaptive learning, learning analytics, and a multi-agent AI architecture, Tutor-AI provides a highly personalized educational experience tailored specifically for IITJEE preparation. Rather than functioning as a simple chatbot, Tutor-AI continuously learns from every student interaction, identifies weak concepts, recommends targeted practice, evaluates conceptual understanding, and adapts its teaching strategy over time. Our objective throughout this project was not only to answer students' questions, but also to help them develop a deeper understanding of concepts through personalized guidance and continuous feedback. We believe this approach can make AI-assisted education significantly more interactive, reliable, and effective for competitive exam preparation. Thank you for watching our demonstration of Tutor-AI. We hope you enjoyed the presentation.